Hello, my name is Evan Sinisak. I'm recording this quick demo video for Info 6017 Artificial Intelligence Project 3. The purpose of this project was to use finite state machines to simulate exploring a graph and also using graph search behaviors to determine the best path in order to simulate gatherers going from wherever their current location is to a resource and then returning it to a home base. So I used the stuff that we were given in class, mainly the finite state machine and the bitmap loader. The bitmap loader I did not change. The finite state machine I have made some modifications to, and the graph stuff that we did, I've made some small changes to that as well. So for this finite state machine, we made this system to handle updating each of the different states depending on whichever one is currently active, and then transitioning to the different states. So our base class that gets inherited from is the FSM state, which has an update, on enter, on exit, is done, add transition, get transition, with a protected current condition and the default constructor and the privated state name and a map of the possible transitions. Where when we add a transition to a state, we set whatever the integer condition will be for the map, as well as what state it'll actually go and enter into. And then we add that state to the condition map. Get transition checks is done, and if it is done, then we return the transition map of the current condition, and is done checks if the current condition is anything other than 0. So the default one, that'll get updated over. I had to do some workarounds for how I wanted to handle this. So eventually what we'll see is that I have these entities that has the finite state machine system on it. So in order for the states to actually affect the entity's position, I pass in and return. I realized just now that I probably should have passed by not reference. I can never remember what it's called when you put the ampersand so that you can change the variable within the function. But I could have done that for the position as well, rather than returning a vec3 of the new position at the end. But I'm not going to change that now. So the first state that the entities will enter is the idle state, which just sets as soon as we enter the idle state, we exit it. This is just the state that we enter from, so we have something to start and we don't immediately start searching if things don't exist. So could add a timer or some other condition to it. But for our purposes, it's fine for it to just immediately go into. So the search state, when it enters, it goes through the graph and finds whichever node it's actually at, and then uses the Dijkstra's algorithm. I can never pronounce that correctly, so apologies. To find the closest resource node. And as long as that target node is not null, then I basically reverse the path. So I go through the while loop, grabbing each parent and pushing it onto the path to target. And then I do a quick for loop that just swaps the first and last, continually getting closer. It just reverses the order. Then in update, let's enter. If the number of resources is ever less than 0, then that means all the resources have been found. So we can enter the end state. But if the number of resources is not 0, then we check if our path to the target size is greater than 0. If it is equal to 0, then that means that we have completed the path and that we should be at the target. So whatever the current node position is, we grab the target's position, grab the direction, normalize it, multiply it by delta time, and then the speed modifier. However, I've been noticing some issues with the larger maps because of slowdown on my computer, so I'm actually going to change this to... We'll try that. I might change this again before I submit after I test it a bit more. But then we just add in our current position in the direction, and once the distance between the target position and the current position is less than 0.1, then we erase the current, like the first element in the vector. And so I have done that now. So when the path is empty, then we do a double check, get the node, and if the current node still has the goal, then the resource is still there and we can collect it. And if it does not have the goal, then we need to find a new resource. So since the logic is already on there, I just run on enter again. And that's it for the search state. After searching, the entities do a gather. So on enter for the gather, again, grab the node that the entity is at, set the has goal to false, and reset our timer and condition. And this just adds to the timer for 4 seconds. And after 4 seconds have passed, we subtract the number of resources and we move on. And then I find the mesh of the resource that we're at and change the color. I'm remembering something I read on the document that I'm not technically doing, but I technically am. It's fine. So after gather, it enters the return state. So on enter, I do the same thing as the search. We find the node that we are currently at. We also have to find the home base. Whatever. I have only tested maps with one base. I'm now realizing that in the case that there is more than one base, that this logic is not sufficient. I should actually probably use Dijkstra's to find the nearest base. But then I would have to write a new version of Dijkstra's just to do that. So for resource maps with one home base, which is pretty typical for video games, we find whichever node has the home base, and then we run the A-star algorithm to find the best path from the current node to the home base. And then again, reverse the path and do everything the exact same as the search state. And if we're close enough to the target, we erase it. And if the path to the target is empty, then that means that we have reached the home base, and we can move on to the oh, no, sorry. If the path is empty, then that means that we have reached the home base. So we wait 2 seconds before we return the resource to the base. Then we return, or then we enter the search state again. And once the number of resources in the world has been depleted, then the search state enters the null state and just stops moving. So this is where the state machine entity I made comes in. As I mentioned, each entity has its own system and a version or a copy of idle, search, gather, and return. With the transitions being between idle and search, state and or search and gather, search and null, gather and return, return and search. Add them all to the system, start the system when the entity is made, but we don't start calling update until our main loop. So the mesh I'm using to represent the entities is just a basic sphere of size 0.3 with this color. And then I'm just storing different colors to represent which state that the entity is in. So we run update, passing in the current position, returning the new position, and then we update the mesh position to represent that. And then we change the color depending on which state that we are in. System. So as I mentioned, the only thing I really changed is an A-star. Instead of checking for has goal, we're checking for is the home base, since we're not using A-star for anything else. Otherwise, everything else here is just the same. Little things, resource, wireframe. So the graph, I added 2 things to the node. I added a type and is home base. The type is of a char. So when reading the bitmap, we have the determined char from color thing that we were given. So it returns R if it's red, B if it's blue, G if it's green, Y if it's yellow, underscore if it's black, W if it's white, and X if it's none of them. So by default, I set the node type to black and is home base to false. But then I just made a new constructor that passes in the type and the boolean for home base and has goal. And then add edge is the same. Print graph, I added just a extra line, or 3 extra lines. One prints out the position of the node. One prints out if the node is a resource, and one prints out if the node is the home base. And print parents is the same, but I commented that out. because I'm not using it. So here in main, here at line, that example doesn't actually work because everything is black and there's no pass. Line 94 to 100 are the different resource maps. 1, 2, and 3 were the ones that were given to us. I explain it a bit more in my README, and I'll show it during this, but resource map 3 seems to be corrupted. I don't know if that's just a me thing or something in the bitmap loader that we were given. I think I've narrowed it down to the fact that the maps needs to be a multiple of an 8x8 square, and the resource map 3 being size 54 screws that up. It's a 54 by 54 because I made 2v2, which is the same size as resource map 2. Resource map 4 is size 32 by 32. 5 is 48 by 48, and 6 is 64 by 64, and they all run fine. 5 and 6 run a little bit slow on my computer because I have to run it in debug. The other thing is that the bitmap loader, when run in release mode, reads every color or every pixel of the bitmap as black or white. So that doesn't work in debug. So when it gets to be so big, my computer is a little bit slow on debug mode. So I basically use the same logic that we were shown to make the graph and meshes. So we read the bitmap image and pass in the data into a char pointer, get the width and height. I just needed some character name for the graph, so I started at A and increase it by 1 every time. Gets to be some very interesting characters, especially in the bigger maps. And then this is just the double for loop that we had in class with the get color character and print that color out. And then I use this C to determine basically everything. So we make a temp mesh of the quad, put it at position YX, because even though it's XY, the Y is actually, because it's going first, it's actually the X position, and then the X increases once, so it goes up. It's reversed. It's fine. It works. It looks good. And then depending on whether the C is R for a resource, if it's R for a resource, then the mesh is set as red, and we increase the number of resources. If it's G for spawn point, it's set to green and added, and a spawn point is added at that position. Spawn points is just a vector of vec3s. B is a home base, so we set it to blue. Y is difficult terrain, so it's yellow. White. W is regular terrain, so it's white. Underscore is black, so it's not traversable. And X means that something went wrong. I had this as purple just to show when something was reading wrong. I changed it back to black, but whatever. And then if something is very wrong with the color, that it doesn't even return an X, which should never happen, it gets set to this color, which I don't remember what it is. RMG, probably orange, maybe, whatever. We're not lighting it. Clear the textures, add the mesh to my vector of meshes, and then create a node at that vertex with the, what is it? Yeah, ID, position, type, Boolean is home base. So if C is equal to B, it's home base. and if it has a goal or it's a resource, then check if C is equal to R. Then I go through a nested for loop of the nodes. So for each node, if the node at index A is black or non-existent, then it's not traversable, so we don't want to make any edges out of it. But if we pass this check and it's a traversable node, then we go through every node that was made afterwards and compare the position. And then, so if it's to the left and it is not a black or non-existent node, then we add the edge with a weight of 10, and it's bidirectional between A and B. And that was the thing I forgot in add edge. So I made a new float in add edge that just temporarily stores the weight, and if the destination type is yellow, then the weight is doubled, and then reset the weight and do it again for the reverse edge. And then it does the exact same thing: left, right, up, down, diagonals, check left and right, or left and above. Then also find the node to the left and above the current node, and if either of them is black, so it has to not be black for both of them, and the node that we're going into isn't black, then we add the edge. So just the same logic repeated for different positions, and then I go through the list of spawn points and make a new entity for each one. Then in the main loop, we run the update on each entity, which just then goes back into everything that we said before. And then I do all of the GL stuff, and then when we're ready to draw, I go through the list of entities, draw, and then the list of everything else to draw. So, come back up here. Controls. Mouse aims the camera. WASD moves the camera. Q and E raises and lowers the camera. Space is not useful, but it locks the camera in a certain position. B shows debug normals. M changes everything to wireframe. 1 through 0 does different graphics effects. So inverse, grayscale, whatever. Just have that on for fun. If you change the size of the window, because I'm using an FBO, if after changing the size of the window, if you press P, it resets the resolution of the FBO, so it doesn't do that gross black stuff. So it already finished finding the first resource. Keypad 1, 2, and 3 will change a variable. Oh, that is much faster than before. Yeah, so that was the issue I was running into when using delta time. When with the bigger maps, the delta time would get to be so big that it would do this and it would move too far past the node it's trying to get to. So it looks like 1, 2, and 3 will work. Apologies for the jump. I tested around with a couple numbers. 0.05 seems to be the most consistent, even at 3 times speed. So just to show it again real quick, resource map 1, reads it out, prints it out, loads everything. So aim the camera, wireframe, press 2 times 3, speed 3 times speed. It does not affect the timers; those are based off of delta time. And as you can see, the edges aren't made correctly, so it does not try to diagonal over any black spaces. That was an issue I had at the beginning. It would go diagonal to get to the home base. That was fun to figure out. So yeah, I don't really have any way to show that the algorithms are really working other than that if you figured them out for yourself, it should, like, you should see that the paths are correct under both algorithms. Like, diagonals are always better, unless it's a diagonal through a yellow, than going up and then left, unless up and then left or right or whatever is a round of a corner. So the entities always seem to do the diagonals wherever possible. So this is the first one that I made. So it has 2 entities and some additional resources. I just made this to show that the 2 entities do work when I couldn't get resource map 3 to work. The ding you hear is one of the node names when it gets printed out. Just the character it is causes the computer to make that sound, which is lovely. And I'm gonna run that. Whatever. I'll run it again because it's the fastest. So 3 times speed. They both find the node that is nearest to them. The one on the right gets to the home base faster and then goes to that node. And then so the node on the left is on its way to that resource, and then the node on the right was at the home base. So it found that that node was the closest one for it to go find. So it gets there, realizes the node no longer has a resource, then finds the nearest one again. And then they both return to the home base, where they then exit. So just to show what I mean about resource map 3 being corrupted, so if I look at this right away, you can see that there are some issues. We're seeing some X's, and there's already 2 B's. It should never see a B unless it's the home base. That is not purple. So that grow screen is everywhere that there's an X. There should be, yeah, so there's the 2 right there. I've tried a few things. I tried doing some color corrections. I've tried remaking the map. It does not like, the bitmap loader does not like it being at this size. So as I mentioned, I made some additional maps to test. So 4 should be the 16 by 6. No. Is this? I think this one's 16 by 16. Anyways, 4. There's 4 entities. Home base is in the center. A lot of resources. I think when I ran it before, it took roughly... This was using the delta time times 3. Trying to remember, it took at least 5 minutes. But as you can see right here, because they're basically all moving at the same speed and getting to each and they all got to the home base at the same time, they all go to the same node. 3 of them move on to the next node because the first one already got there. Then 2 of them move on to the next, and then the last one moves on to another, to the next closest again. So this is on 3 times speed right now. You can see that it's moving considerably slower than the other ones. But basically, they all get the resource that's closest to them. Then they get the 2 at the bottom that are closest. Then because of the yellow at the bottom, they move to the right, get those, and then they get the 2 on the sides. In fact, the one far left is getting the resources over there instead of trying to go through all the yellow. I didn't see where it started from. It was... Yeah, because now they're gonna go get the... Okay, so the same thing is happening to the one on the right. It was on the right. Realized all the nodes over there were already collected, so now it's gonna gather those. Might as well have something before returning to the base. So now they're going to gather the 3 at the bottom. And then the remaining 6 on each side. It's not too long for this one. This was considerably longer when using Delta Time because of the slowdown. And because of the slowdown, Delta Time was bigger. So even running it at 3 times speed, it would cause that jumping issue I showed before, where it was moving too much, so it was moving past its target and having to go backwards, and then it would just keep hopping back and forth. Oh, that 4th entity is going to be sad when it realizes all the others are gathered. So the 2 are going to return to the home base. Depending on how... I think the first one's going to search. They're all going to search. So they're all going to end on that square, except for the one that's... Oh, nope, never mind. I guess... Yeah, because the resource is gathered now, so they just stop. Nothing to do. No resources remain. I'm not going to run through all of 5 and 6. I just want to show that they do load correctly. 5 is 48 by 48, and it shows this nice heart. So again, I'm not going to sit here through the whole thing, but you can watch them go through and collect all the resources and just watch the heart slowly turn from red to orange. I'll let them finish 1 pass at least. This should be a good showing that they don't diagonal over non-traversable squares. They're going diagonally directly towards that, then they go straight down, diagonal past the yellow into the home base. So, because of my slowdown on this computer, it's going to take a little bit too long. And this last one is 64 by 64. So again, even larger, but it does load correctly. As you can see, it is massive. Camera does not want to move. Stabilized a bit. So, yeah. Loaded correctly. They're all gonna... How many is that? 1, 2, 3, 4, 5, 6, 7, 8. 8 gatherers, a lot of resources. And it's going to take forever. So again, If you do resize the window, just press P and it'll fix it. And keypad 1, 2, and 3 will change the movement speed of the entities. Not the timer speeds, just the movement speeds. So yeah, that's going to be it. Thank you for watching. So again, lines 94 to 100 to just quickly change which map is being used. I forgot to add that to the README. Thank you for watching.